Hey Math 1, I'm back for the test review number 1, video number 2 of me going over the even numbered solutions. So, we got a number line here. I would like to split this up into kind of two different categories where it's like, we've got like Owsley strategies, the ones that I talked about in class. And they're not my strategies, but they're different from straight up calculation stuff. And I kind of want to show a comparison of each one so that you guys can get kind of a final look at what I'm talking about between the two. So here's the first one. Letter A, negative 7 divided by 9. The calculation strategy would be to say, I got to put the 7 in the box, the 9 on the outside. 7.0, 9 goes into 70, let's see, 9 times 8, 72, so it's 1 less, it's 7. All right, and now I need to figure out, because 3/4 is 0.75, I need to figure out if that's more than 7.5 or less than 7.5. So 7 times 9 is 63, subtract, you get 70, and then it drops down again. This is 7/7. Okay, it's negative 7/9. So I have to go from 0 left to negative 3/4, which is negative 0.75, and go a little bit more. So there's A. So there's the calculation strategy. My strategy, negative 7/9 is instantly negative 0.77 repeating. Because if it ends in a 9, all you got to do is take the top digit and repeat it. So what I'm saying is commit it to memory, and so that when you recognize that, you can just go for the solution right away. Where's my eraser? Okay, here we go. Letter B. The pure calculation strategy for 6 divided by 13 is to put 6 in the box, 13 on the outside, put a 0.0, and go to town with it. So 13 goes into 60, 13, 26, 39, 52, 4 times. And I don't know, usually when you guys do that, you like find an extra digit too. So 60 minus 52 is 8, 80. 13 goes into 80. Let's see here. Is it 7 times? Is it 6 times? It's 6 times. 6 times 3 is 18. Carry a 1, 78. All right. 0.46, and it's positive, is just below a half. My strategy is to say 6 over 13. Well, 6.5 is half of 13. So here's a half. It's less than a half, but not by much. So put it less than a half, but not by much. All right. For part C, there is no distinction between Owsley and calculation. Root 9 equals 3. You guys just straight up need to know that. All right, negative 17 over 18. Again, calculation strategy. Put the 17 in the box, the 18 on the outside. You ask yourself, how many times does 18 go into 170? You know, you guess and check, you guess and check, you guess and check. Eventually, you'll get to 9. So 9 times 8 is 72. Carry the 7. 9 plus 7 is 16. All right, and usually you guys just by default will get a second one there. So 18, 36, 54, 72. There's 4 of them. And that's usually enough. It's 0.94. So your job is to know that 0.94 is just less than 1.00. It's right here. If it were positive 17 over 18, it's negative. So you have to go left all the way to almost negative 1. Here's my strategy. 18 over 18 is equal to 1. So 17 over 18 is just 1/18 less than that. 1 over 18 is a very small decimal. It's just barely less than 1. Or, if it's negative, it flips the sign around. That's just greater than 1. So it's a little bit right of -1 on the number line. On letter E, it's probably just a safe bet on that one to do 2 divided by 7 for you guys. 2.0 on the inside, 7 on the outside. 7 goes into 2.0 almost 3 times. 7 times 9, 63. So just less than that. 0.8. So your job is to understand that this is just a little bit more than 0.25. 0.25 is a quarter. So this is like 4 1/4, but a little bit more. So here's 4. Here's 4 1/4, and it's just a little bit more. I guess my strategy would be 2 divided by 8 is equal to 1/4. So if you reduce the denominator by 1, but it still has the same numerator, this means it must be bigger than 1/4. I didn't really talk about that too much in class, though, so I wouldn't make that your go-to strategy. All right, -√26. There's not really a difference between my strategy and a calculation. You have to know that √26 negative is just more than √25 that's negative. 5 times 5 is 25. So this would be like -5.1, -5.2, something just left of -5 on the number line. Okay. And then G, you could just straight up do the division. Again, 5 goes into 17 3 times. Subtract, you get 20. Move the decimal up here, and it's 4 times. 3.4 is just between 3.25 and 3.5. Between these two notches, 3.25 and 3.5. So it's in between those two. I really don't have an extra strategy for that one. All right, a lot of you guys need to work on this. All right, number 12. We are on the formulas. Hold on. There we go. Now, on the test, I will offer a bank of formulas, like I always do. Your job is to go back and make sure you're writing the correct ones down based on what you're given in this statement. So here, it says find the area of a trapezoid with a height. You know what? I'm just going to draw the trapezoid to remind myself of what's going on. So here's a trapezoid. Its height is 3/4 of an inch. The shorter base is 1 1/4. The longer base is 2 3/8. And we have a formula for that. We got a bunch of formulas. So just make sure you are very, very, very detailed, or not detailed, but just you're paying attention. This is the formula I want. Sorry, this kind of gets in the way, but the area of a trapezoid is A equals 1/2 times H times the base 1 plus base 2. All right, so you've referenced it on the formula sheet. You wrote it down. And now we calculate. So don't make that the hard thing. Don't make the identifying of the formula, writing it down, and then plugging in the difficult part. The difficult part should be the calculations themselves. So the height is 3/4. We could say this is base 1, 1 1/4, plus base 2, 2 3/8. So recognize that the operation here is multiplication. I can do the stuff inside the parentheses, but I can also do this multiplication before that multiplication happens. All right, so I don't want to confuse you. Let's do the stuff in the parentheses first. Let's make these fractions. So take 1 times 4, you get 4. Plus 1, 5/4. 2 times 8 would be 16. Add the 3, you get 19. All right, so the stuff inside the parentheses, we do that first. To add two fractions, you have to find common denominators. So 8 is a completely great, we can use 8. 8's fine. So multiply the bottom by 2 to get 8, multiply the top by 2 as well. So you get 10/8 plus 19/8, and that's 29/8. So inside the parentheses, you get 29/8. All right, I'm going to erase that now so we can have a nice, neat patch of work. Just pause it and go back if you need to see the work again. So 29/8 is in the parentheses. You don't need to keep these parentheses anymore because it's like there's one number in there. Nothing's really happening that changes when you just get rid of them and put multiplication. So then your last move is, how do you multiply fractions? Well, you look at their diagonals. Do they divide anything? No, they don't divide anything. So then you just go straight across. 1 times 3 is 3. 3 times 29. Can you guys see that? Yes. 9 times 3 is 27. Carry the 2. 3 times 2 is 6. Plus 2 is 8. It's 87. And the bottom is 2 times 4 is 8. Times 8, 64. So, area is inches squared, and it's 87/64 inches squared. You know what? You don't need to turn that into a mixed number or a decimal. But for the record, it is 1/23/64. So it's not a big area. All right, last one, number 14. Find the area of the shaded region. So we're still dealing with geometric formulas here. But the overall concept is you take the area of the big shape, sort of like the one that is the outermost boundary. The area of the big, and then you subtract the area of the smaller shape inside. It's sort of like cutting a donut hole out of this triangle. So we go to our formula sheet if we don't have these memorized, and we ask ourselves, what's the area of a triangle? Got it? That's the big shape. So we're doing 1/2 times base times height. The small one's a circle, so we're going area of a circle, pi r squared, minus pi times r squared. Base of the triangle is 18. Height of the triangle is 10. Pi is 3.14. radius is 4. And now we just do the order of operations. So I can solve the circle independently of solving this triangle. Like what I'm saying is, as long as they're separated by a minus, I can do 1/2 times 18, which half of 18, 9. And then call that 90. I can do that before I do the square here because it's like it's on the opposite side of a minus. So just throwing that out there for you. So 4 times itself is 16. So I'm going to take 16 times 3.14 over here. So that'll be one of the tough calculations of the actual problem. 24, carry a 2. 6 plus 2 is 8, 18. Drop a 0. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Add them. 4, 12, carry a 1. 10, carry a 1. 3, 4, 5. The decimal is 2 digits to the right, which means I need it 2 digits in. So that's 50.24. And I'm subtracting that from 90. So make sure at this point, 90 minus 50.24, you are required to put a 0.00 here. Yeah, I mean, here's what you could do informally. What's 90 minus 50? It's 40. Now take away 0.24 more. Well, it's going to be 39 point something now. You can use that informal logic to kind of guide your final calculation here. You have to take 0 and borrow from here, and then borrow from here, and then borrow from here. 6, 7, 9, 3. Oh, it's 39.76. Makes sense. You take away 24 from 100, you get 76. And since it's area, we're doing square centimeters. All right, guys. Hey, thanks for watching. I know sometimes it can be tough just watching someone work it out, but I hope this is really helpful and it's clarifying some things for you.